Okay, good morning, students. I'm just starting the class. So today I'm going to discuss about kinematics. Okay, so before we have already we have discussed mechanics of particles, and the next one we have completed 3 units. So what was the second unit? Collisions. Linear momentum and collisions is third unit, and the second unit we have done. That is vectors and scalars. Our calculus was the second unit. First one is your scalar and vector. Okay, first one is mechanics of particles. Second, we have done with the vector calculus. Third, we have done with your linear momentum and collisions. Now we need to discuss about kinematics. Okay. Okay, shall I start? Somebody need to respond so that it will be like interaction. Okay. So what is kinematics? What is kinematics? Can anybody tell me in general? In general, what is kinematics? So we are going to study kinematics in one-dimensional rotational motion. If we understand what is kinematics, then rest of the things are very simple because we know what is acceleration, what is velocity, what is motion, what is rotation. We know all these topics. So we need to know why the heading is kinematics. So regarding this kinematics, we are going to discuss all these topics. Rotational motion, rotational kinematics, angular velocity, angular acceleration, rotation with constant angular acceleration, analogies between transmission and rotational kinematics, relation between linear and angular kinematics of a particle for a particular fluid, circular motion. These are the topics we need to discuss. So we need to know what is kinematics, so how it works, why we need to study kinematics, because now we are able to understand what is linear momentum, collision, vector calculus. Okay, what is a particle, how the particle starts moving from one place to another place. Okay, so if we are giving some external force, how the things work, that we are going to study here, kinematics. Okay, so kinematics is nothing but the study of the motion of mechanical points. So what are the mechanical points? Nothing but if you are giving some external force to that any motion which starts working. That might be bodies, that can be system, that can be anything without consideration of their associated physical properties and the force acting on them. Okay, the force which is acting on them is nothing but a kinematics. We can study and we can also find the geometry of the motion and the models which can be used with the mathematically or using it. So let us see the introduction, what they have given for this. So what are the objectives? Objectives after going through this unit, you will be able to explain the rotational motion of living bodies confined to a fixed axis of rotation, describe analog between translation, the topics whichever, whatever we have discussed. So they are giving the objectives in this way. So what is the introduction? What is kinematics? So we need to know before going to kinematics, what is kinesis? It's a Greek word. It means emotion. Okay. As I told you, kinematics is nothing but an external force should be given to a particle or any object or any body which do some work. The word dynamics means power. Dynamics means, yes, this person is very dynamic, that person is very dynamic. They are having a dynamic means a power, which if, if somebody speaks, we can say the dynamic person because of that speech, the power, the energy which is coming out, we call them as a dynamic. Okay, so the word kinematics is nothing but a Greek word which is combined and able to speak on that word because dynamics is nothing but a power. So kinematic is a branch of mechanics that describes motion while dynamic explains the power. Before we go into detailing kinematics of rotating bodies, it would be worthwhile to recollect the basic principles involved in kinematics of bodies in translatory motion. The following section deals with the kinematics of bodies executing translatory motion. For example, if we are taking, we need to discuss about linear angular velocity, angular acceleration, linear acceleration, angular. So what do you mean by velocity? What do you mean by acceleration? What do you mean by acceleration? Somebody. It's a general question. Answer. Students, I need some answers from your end also.
What, madam?
What do you mean by acceleration?
Acceleration means change of speed with respect to time.
In general. Yeah, perfect. You gave the perfect answer. Simple words. What do you mean by acceleration? Means, okay, body which is moving from one place to another place. In general. Okay. In physics terms, you told the excellent. So acceleration is nothing but the rate of change of velocity. Okay. Which means the speed is changing. Speed is changing. See, I can drive a car in 10, 20, 30, 40, 50. Depends how I am accelerating. According to that, the speed of the body will be changing. Okay. Even if I'm giving a competition for a two persons, I ask them to run. Okay. So the velocity and the acceleration of the speed will be differing from one person to the other person. Okay. When an object means anything, that might be a vehicle, that might be a person, anything we take. When an object moves in a circular path at a constant speed, it is still accelerating because the direction of its velocity is changing. This we need to remember. They can go in a straight way, they can go in a circular path. Okay. Okay, circular path at constant speed. It is still accelerating because the direction of its velocity is changing. This we need to remember. Clear? Shall I go further? So we understood what is kinematics. Is nothing but a power which helps to have the motion of the work, and we know what is acceleration because why I am talking about much about the acceleration, because of the acceleration only the things work, right? So kinematics in, yeah, kinematics in one dimension. So if we can find for one dimension, we can find for a number of dimensions. So here they say that in mechanics, the motion of a body is described by assigning a property to it is called particle nature. In nature, we do not come across with bodies which have no size. Nevertheless, real objects at times behave as though they were particles. A body needs not to be small or so as to be treated as a particle. So, for example, the motion of the planets around the sun can be described by treating them as particles. Anybody which has only translatory motion behaves like particle. So, we are just talking for one dimension. We can observe that. See, one particle is there, atoms are there, molecules are there. Okay, electrons are there, neutrons are there, protons are there. So many we have in our nature. Okay, how it is behaving, how these particles are rotating. See, for example, all the planets are rotating around the sun. We know that. So, sun is not moving. Only the planets are rotating around the sun. So that's why we are getting, if we take the earth, if earth is rotating around the sun, what it is happening, we can find the day and night, right? Day and night, we are able to get it because earth is rotating. Earth is rotating around the sun. If earth is not rotating around the sun, if it is stagnant at one place, what happens? Only we get a light. We don't get a darkness, right? So, because Earth is keep on rotating around the sun, we are able to see the light as well as dark. Both we are able to see that. Okay, so this is an example of a kinematics, how the planets are around rotating around the sun, which describes treating them as a particles. We are talking about a particle. So we go further in depth of the particles. So to find out, say why we are studying this, why we want to study, because a if a rigid body is there, example, I'm going little further. A rigid body is there. A rigid body is nothing but which does not move from one place to another place, like a sun. Okay, a rigid body is there, but all the electrons are ready to rotate around the rigid body. So why we want to study, why we are studying this? Because the energy which is being transmitted to the fixed body also. And you are able to understand why I'm just trying to give you this input. So further, if we study next topics, we are going to focus and study on this only, how these particles are rotating around a rigid body. So if the rigid body is fixed, how these particles are helping, because their mechanism is there, kinematics is there, acceleration is there, definitely there will be motion. So we are able to find the velocity, acceleration, linear motion, everything we are able to find. Next topics also I'm just discussing to have a basic information. Okay, clear? So here you can see an observer will consider the motion of a body to be translation into the axis of a reference. So if I'm talking about particle, so first I want to find for one single particle, then I'll go with the second and third. Okay, so let us see the axis, x-axis and y-axis is being taken. So here an observer will consider the motion of the body to be translation if the axis of a reference frame, which is imagined to be rigidly attached to the body, say x, y dash and z dash. Okay, y1 and z1 remains always parallel to his own reference frame, say x, y, and z. We know the axis. If I'm taking a one single particle, if I want to find the single particle, I can find x, y, z axis. Right? X axis, y axis, and z axis. So I can, if I could find for x axis, I can find for y as well as z. So I can find the coordinations of the x to y to z. I can write the coordination, right? As I told you in the last previous class, how the collision takes place, how I can find for one single particle, how it is being vibrating and re-radiating. If I'm able to find, I can find for n number of particles. Right? You are on with me?
Yes, madam.
Everybody. Yes, right?
Yeah.
So, yeah. So with that one single particle, if I'm able to find for the axis, why I'm finding axis? Because I'm talking about a single particle. If I could find a single particle, I can find for n number of particles. How? Why? Why should I find for n number of particles? Because it is coordinating the axis, which is x-axis, y-axis, and z-axis. If I could find for one coordinate, one particle, the rays, for example, a light is fall on this. If I'm taking this as an electron, okay. So the light rays passes on this electron. So what does it do? Electron starts vibrating and re-radiates. So what does do here? This particle may be started vibrating, but here also may be one particle. Here also it may be there. Here also it may be there. So the particle to particle it differs. One particle may be so dynamic than another particle. Okay, what it does, this particle may radiate and give the energy to this way, that way, for the back of that, front of that. You're getting? So the particle which is started vibrating and re-radiating means it is the energy is being transmitted in a way. This electron is not moving. This only re-radiates. The energy will be re-radiated and hit the another electron. So by calculation, I'm telling you in the theory. So I'm telling you what the electron starts vibrating and re-radiating. So what does that electron do? How it is re-radiating? How I can calculate? How I can be in application? So the mathematically, theoretically with mathematically, we need to prove. Everything, whatever we do, is an imagination or it might be a theoretical, which theoretical is genuinely observed and done the verification that should be calculated in mathematics to get a result. I'm telling you the theory. Okay, I'm telling you this electron starts vibrating and radiating. So the radiation hits this electron, another electron, another electron, another electron. The process will be happening. But where or how I can find out? I want the output. I want to use it. You're getting me? So I want to use this energy, the dynamics, the power. The power should be used, no, to get the flow of the charge. So to find out that the single electron, the single particle is being calculated. So what I have done? So in this single wave, single axis, they are taking the particles and they are able to find the axis. So x-axis, y-axis, x-axis, y-axis, x-axis, y-axis. Clear? So here you can find the position of the body, say A, B or C. The axis of the reference frame attached to the body, that is X and Y1, always remain parallel to the axis of reference frame, that is X comma Y. The path taken by the body needs to be the straight line. Okay. Every point of the body undergoes the same displacement. Why? If I'm talking about an electron, however it will be traveling, it will be in a straight line. That might be S, K, whatever the shape you take. It can flow in any direction, but it goes in straight line. Okay, every point of the body undergoes the same displacement as every other. We can treat the body to be a particle, since by describing the motion of one point of the body, we get the description of the motion of the body as a whole. So did you understand? So one dimension is nothing but if I'm taking a one single dimension, if I'm able to find for one single dimension, I can find for a number of dimensions. Dimensions are nothing but I am taking for this particle, one dimension. I can find for, see this, after next over here it is there. Next, one dimension, two dimension, three dimension. We can find for n number of dimensions. Next, front I can calculate. Back of that, if I want to calculate, I want to take it in a dimension model, cubical model. Yes or no? Cubical model only I can take and find the dimension. Okay. See somebody, I'm getting disturbance, please mute. Please mute somebody. Okay, so we shall now briefly describe the parameters characterizing the translatory motion. Consider a particle moving in one dimension, say along x direction. So first what we will find for x direction, we will find. If I am able to find for x direction, I can find for y and z. Clear? So x I am taking. This x direction I am taking. For x direction, if I am able to find the coordinates for x direction, what the coordinates can be, if I'm finding for x, x will be 1, y will be 0. Right? If I'm able to find for y will be 1 and x will be 0. If I'm
0.
taking z, x and y will be
0.
0, z will be 1. So if next coordination, if I want to find over here, the same dimensions will be there. I can write the coordinates for x, double x will be there. For if I'm writing one more particle, if I'm there, one more particle is behind that first particle. So what I can write? Tell me, just tell me, if one more dimension is there or one more particle is behind this particle. So what will be the coordinates? Tell me. So x will be x. What x will be for x axis? I want to find x, y,
X,
z. I want to find. Okay.
X will be 2.
Hmm?
X will
No,
be 2.
x will be 2. So definitely I'll write for that coordinate only, no? That will be x, for example, 1 dash, and y will be 0, z will be 0. No, we can't write it as 2, 3, 4. Okay. X1, 1 dash, 2 dash, I mean 1 dash, 1 double dash, 1 triple dash, like that we can write x. You got it? X, as you told, but I am writing for that coordinate only, no? I'm not including this. You got it? See, if I'm able to find this coordinate, if I want to find for behind of that coordinate, that will be also same, no?
That
For
will be
that,
also same X, Y, Z only. We can say it X double dash, Y double dash.
yes, exactly. Got it, no?
Yeah.
Understood. So we can write front, back. So if I'm going this way, so this will be the positive, this will be the negative. So what will be this? X-axis, it will be -1, and y will be 0, z will be 0. So if I'm going in this negative axis, I can write for y as -1, x and z will be 0. For z also, z will be -1, x and y will be 0. I can write the coordinates front, back in a cubical. So that is what is a dimension. If I'm able to find for one dimension, I can find for n dimensions. If I find for x-axis, I can find for x direction, I can find for y and z direction. Here, they will not talk about any coordinates. Further, for your understanding, definitely the calculation part will be x, y, z. Further, what we have to do, how this coordination, if you do your next further PG course, there they will come this coordination part. Got it? So, to understand this concept, I'm telling you right now, why we need to find how this is happening, how this coordination is happening, how this axes are, if a light passes on any particle, how it vibrates and radiates. Topics will be taught in your PG level. Okay, now we are just finding how these dimensions are taking place, how this axis can be calculated. Okay, we have taken only x and y over here. I've told you about the z also. If I'm able to find for x and y, I can find for the z direction also. Clear? So this is your basic level. What we are talking about the subject is basic level. What I'm trying to give you the input is your PG level. So if you understand the main concept, how this is happening, how these directions are going on and this and that, that will be, if you study the rest of the topics, everything will be easy. Nothing complicated. Okay, so I'm not going step by step. You just go with this, how these calculations are going on. So you are able to find for one dimension. That is your x. So next comes here. So here I could find for the velocity and as well as the direction, x direction. If the acceleration of an object is not uniform, then the velocity and displacement can be given by. So by calculating, by understanding how this displacement of the particle and displacement of an object can be calculated. So here I have taken delta V is equals to V2 minus V1, that is integration of T1 to T2, A of dt. So then I can find for x-axis. So x delta x is equals to x2 minus delta x means I can find for x-axis whole x2 minus x1, that is integration t1 to t2 v of theta. So here next comes rotational motion. I'm trying to help you out to find the concept. Okay, rotational motion. What is rotational motion? So if a rigid body is fixed, I told you already these topics were taught in your last previous class. What is rigid body? How the motion takes place. For example, if a pole is fixed, which is a rigid body. Okay. Now we are transferring the power. Okay, the transformer is helping to transmit the energy to the poles. Through the poles, we are getting the charge to all. Power is getting to all the places. No? Each and every home, each and every place, we are getting the power. We don't have separate poles at our own place, right? Power is generated. You are understanding?
Yes,
I'm telling the complete the whole topic, how this is helping us. Why they have taught you the single each and every topic, because they are finding out how this is taking place because of the rigid body. When a rigid body is fixed, okay, when a rigid body is fixed, when the electrons are revolving around that, how this energy can be transmitted. So the rotational motion, why we are talking about the rotational motion? Because a rigid body is fixed, and then energy will be transmitted around that rigid body. So the rotational motion is an important characteristic of most of a machinery used in the present day world. So see, they are talking about the present day world. We cannot come across any machine without a gear, wheel, or rotating shaft. The simple cart makes use of the rotational motion of the wheel for its translatory motion. Most general type of motion which a rigid body can undergo is a combination of translation and rotational. To describe the motion of a body which rotates as it moves, we have to specify its position and its orientation with respect to the reference frame. Consider the motion of a rigid body. So, for example, if I'm taking a cycle or a scooter or a car, so what it is having? The wheels, the rotating wheels. So I have a velocity, I have an acceleration, I have a displacement, I know where to go, everything. If there is no rotational motion to that body, does it move? Does it move from one place to another place? Everything is fixed. Fixed to the car or vehicle or a bicycle, whatever if you have taken. Okay, everything is ready, but there is no rotational motion. So what happens? Does not move from one place to another place. So what we have added? A rotational motion is being added to a rigid body. Rigid body is nothing but if I am taking a, for example, a two-wheeler is taken, a body is taken. Okay. So I have added two wheels to that. So that rigid body, it started moving from one place to another because it's heavy. Rigid body is nothing but a heavy body, which cannot be moved from one place to another. But if I'm adding a wheel or rotational motion to that, it starts moving, no? Acceleration is given, velocity is there, displacement is there. I can start moving that body from one place to another place. So the whole world is working on this rotational motion. Understand? So this is about the rotational motion, how the fixed body starts moving from one place to another place, how it is rotating, how this can happen. So rotational and translation motion of a rigid body. So if we are talking about single topic, that is rotational, and it is rotating, and it is translation motion of a rigid body. So the reference frame is fixed of the body changes, and it talks about the fixed axis, how this axis can be fixed. Okay. So for example, if I'm taking a rotating body and I have fixed x-axis, y-axis, and z-axis. So it starts, this is a particle. What it does, it starts moving from, I can take any direction. If this particle is moving in this direction and moves in this direction, it's continuously moving, no? Continuously it is rotating. Okay. So plane rotation is associated with the bodies which rotates about a fixed axis, that is without any translation, as shown in this figure. Okay, rotation of a rigid body about z axis. See, we are talking about a whole body as well as we are studying about a single particle also. Single particle which is rotating. For example, I've taken x-axis, y-axis, and z-axis. How this is rotating around this axis. That is moving in this direction. This direction. Okay, hence here the body rotates about z-axis. Every particle on the rigid body, say P moves in a circle at the center of the circular trajectory traced by the particles in the rigid body fall on straight line, that is OZ. See, the particle electron might be going in a circular path, still it goes in a straight line. Means it does not go however it wants. It goes in a proper flow of the charge. Okay. So we shall now describe the rotation of the rigid bodies by defining the variables characterizing the motion. The describes of rotation is called rotational kinematics. So what is rotational kinematics? So angular velocity is it. Okay, just read how this angular velocity works for rotational kinematics. Okay, so we are able to find, see, if I'm a particle is moving, so I can find the angle this way, everywhere I can find, you know, every direction I can find the angle. So rotation of a rigid body about a fixed axis, see, axis is fixed and it is moving. I can find the angle for this direction, all the circular path of this direction, I can find. That is nothing but your angular velocity. Angular velocity. Okay. So I can find this angle, I can find this angle, I can find delta theta. Means I can find further all the directions, P1, P2, P3, P4, P5, how much the angular displacement of a rigid body under rotation. So I can find the each and every angle and I can find the displacement of this rigid body under the rotation. Under the rotation, I have calculated. Why? Because to find the energy, ultimately what we need, power. By and taking each and every angle and the displacement, angular displacement we call. First we could find angular velocity. Next we are finding about angular displacement. Because I want to find the whole angular displacement of the rigid body under rotation. So I am able to find when it is rotating, I am able to calculate. Clear? I am able to calculate when it is rotating also. So that is what about this angular velocity and angular displacement. Clear? Next, we talk about angular acceleration. So, angular acceleration. What? So, we know velocity, displacement, now acceleration. So, how the body is moving from one place, it is rotating. So, I am talking about a wheel. How the wheel is rotating, how it is happening. But acceleration is nothing but moving from one place to another place according to the time, energy, displacement, or whatever the angular displacement of angular velocity. So when the angular velocity of a body changes with the time, and the body possesses angular acceleration. So that is what we are talking about. Okay, if omega 1 and omega 2 represents the instantaneous angular velocities of the bodies at a time d1 and d2 respectively, then the average acceleration alpha is given by, so that is w2 omega 2 minus omega 1 by time t2 minus t2. That is the equal delta omega by delta. So here we are able to find the acceleration. So the distance is being calculated. Time is being calculated. So how in Google Maps, how it is showing the distance, how it is showing the time, everything is being calculated, right? If you are keeping the Google, the location, it is showing the distance, how much distance it is you need to travel from one place to another place. It will show you the time also, how many hours you'll be reaching from one place. How they have done without this basic knowledge, they could do this. Google Maps can be worked out. No, these all is being taken. This all calculations have been done. So that is what is the software. No, now we are using. See, in olden days, it was not possible. No, now we have Google Maps. We are able to find out how much distance it has been, how much we need to travel, how much time it is taking, how much distance it is. Everything we are able to see in the Google Maps and we are traveling. In those days, there is no Google Map. So the people used to travel and travel. They don't know how much distance, how much time it takes. Understand? Now we are in sophisticated life. Everything is in our hands. We know. Those days it is not there. So they used to travel. They used to travel. They used to suffer a lot, right? So this is about the instantaneous angular acceleration may be defined as alpha is equals to limit of delta t to 0, that is delta omega by delta t, that is d omega by dt. Angular acceleration is expressed as rad dot s to the power of minus 2. So rotation with constant angular acceleration. So rotation will be there with a constant acceleration. So it means constant acceleration can be the analogy between translatory motion and rotational motion can be understood by considering the rotational motion characterized by constant angular acceleration. Let the angular velocity of the body change by equal amount is equal intervals of the time. That is, the body is moving with constant angular acceleration. So we need to remember, we know that what is acceleration, d omega by dt is equal to alpha is constant. Omega is nothing but alpha dt. So integration on either sides, we get integration d omega is equal to alpha of integration dt. So omega is equal to alpha t plus c1. So c1 is nothing but constant of integration. So we are theoretically we are saying, mathematically we are calculating to find the both velocity, distance, displacement, and angular velocity, angular displacement, and angular acceleration. Okay. So where
Madam,
C1 is a, yeah.
how this 4.24 we got?
Here we are taking now, this is omega is nothing but acceleration. Alpha is nothing but constant. So it is C. Circle is there. Okay. I am moving this particle continuously in a constant acceleration. Got it? So that is nothing but acceleration is equals to alpha is nothing but constant of dt. So what we are doing that to find out in mathematical, we are using this integration. So we got this d w by d theta is nothing but, we call it as, we are taking an element. You can take alpha, beta, gamma, whatever. This is nothing but constant because constantly it is rotating, no? The acceleration of that velocity, displacement, whatever we are taking, it is constantly rotating. Understand? Constantly it is having an angular acceleration. Keep on rotating. See, wheels, no? For example, let me give an example. How the wheels are rotating continuously, constantly, because it has an angular acceleration. It is not rotating however it wants, right? Because we have framed that wheel in such a way, it should have a continuous angular acceleration. If it is not framed in such a way, then it does not move, no? The difference will be there. But without having any disturbance, it is rotating continuously. Continuously. The car wheels or bike wheels, whatever you take, what it is having an angular acceleration which is constant. Got it?
Yes, madam.
Oh. So this is what we are going to find for the angular acceleration. These are the equations where we are able to find for the constant angular acceleration. Okay. So next will be the analogies between the translation and rotational kinematics. So what is a translation and what is a rotational kinematics? So rotational kinematic is nothing but a power, which is an energy, which should be given to that. So if I'm not giving acceleration to that body, the wheels not rotate. It will be in the same position, right? So there exists close analogy between the parameters characterizing rotational motion with a constant angular acceleration and those of the translatory motion with a constant acceleration of the rigid body. So what we are talking, we now see somebody have discovered velocity, acceleration, what is angle, everything is combinedly we are framed a body and we have added this rotational motion to that. See, everything is discovered, no? Everything is discovered. A body, whatever the things we are using right now, everything was being discovered. See, wheels have been discovered. So added to that car body is made in such a way that you can give the acceleration, you can give the different energy. Means you can go with the 10, 20, 30, 40, 50. How much gearing, the speed will be increased. Everything is being invented and added all this, then we are using it. So what we are studying is nothing but when they have discovered all this single, different mechanisms that is being added for the whole thing and we are using it. So what we are studying is how this is being used, how this is being invented, how they have find out. That is what we are finding out with a theoretical basis, with a mathematical to find out. See, whatever omega is not being taken from something else, that is being taken from the acceleration. Okay. So alpha is nothing but a constant. B is nothing but a velocity. A is nothing but a acceleration. So this is a rotational kinematics and this is a translation kinematics. So what is rotational? Omega is equals dt by d theta by dt. We know time and acceleration. Alpha is nothing but constant. That is d omega by dt. So how this translation kinematics works for velocity, acceleration. So we could find for del omega, we are able to find for delta acceleration. That is nothing but T1 to T2. Why we are taking this? To find out the proper calculations. To frame, to construct, to do the mechanism. Understand? So this is a rotational kinematics. This is a translational kinematics. For the special case of a constant acceleration, alpha is nothing but constant. We know that if alpha can be a constant, okay, then A is also constant. Clear? Acceleration is also constant. So when we can find for acceleration, we are finding for the velocity. These are the equations which was being taken from rotational kinematics to translational kinematics. Translational kinematics is nothing but which we are using for the application. Got it? So we are able to find for theta, then we are able to find for x direction. We are able to find both acceleration as well as for the direction. X direction means nothing but we are taking for the straight direction. Clear? So now if I go for a straight line, I can go for the minus, that is minus x also. That is reverse. I can take reverse and I can go also, right? So this is the calculations which they have done to find out the different angles, velocity, displacement, everything is being calculated. With this help of this calculations, theoretical, mathematical, that is what further is implemented. So we are talking for a single particle and we are talking about the whole body also. I'm talking for a single, see, I'm talking for a single electron to the body which we are using in our daily life. That is our any body. That is might be car, bike, cycle, bicycle, whatever. The single particle working the current which we are using, which is coming out to the body which we are using, the rigid bodies which are being accelerated and able to work from one place to another place. You're getting me? I'm talking with a single particle with a bulk particle also.
So, madam,
Hmm.
you mean to say this translational is the equivalent, we can say, in the linear motion?
Yeah, definitely. See, linear motion is nothing but what which is traveling from one place to another place. Yes or no?
Yes.
Which is going in a one direction. If I'm
Yeah.
talking about a current, if I'm taking the electrons, how the electrons are traveling?
From one direction to another, one
So
place to another
electrons
place.
will not collide with each other, no? How, like gas molecules or water molecules, right? It goes
Yeah.
in a one straight line, right? So it
Correct.
goes in a one direction. The current which we are getting continuously is because which is having only positive half cycles. It is also going in a wave. The electrons which are traveling will also be in a wave. But what we are neglecting a negative half cycles and we are connecting only positive half cycles because if it is taking a positive and a negative, what happens? The DC will not happen. It will be having a AC, alternating current, positive, negative, positive, negative. Means the light will glow, off, light will glow and off, glow and off. So which distracts us, right? So the invention is being done in the process how the current is flowing. So the negative half cycles have been neglected and we are getting a positive half cycle. That is the electronic subject. Again, if we go into that topics, no, the negative half cycles will be again converted into positive half cycles by giving the feedback. Okay. How this feedback is being connected. So how this negative, because they don't want to waste any cycle, any charge, any power. So that's why that I'm talking about single particle to a bulk particle. You
Right.
got, right? You got it? You
Yeah, got it.
please try to imagine the way I'm trying to help you out because if you understand the whole concept, the theoretical, whatever you are studying and reading, no, it will be like so simple. You will feel that this is the invention is being done because of this one single particle they are able to find. We are next what we have done. So one single particle, if it is rotating continuously, the rotation is taking place. Because of this rotation, the displacement, velocity, acceleration is being added to a big body. That is nothing but wheels. Wheels are being invented, right? How does mechanism takes place? See, if the manufacturer is having a car showroom, so how it is being manufactured? The tires will be from X, the body parts will be from Y, and the whole body is being constructed with a so and so. Yes or no? Everything is not done with the same what? Same uh, company. Definitely, they are going to purchase from XYZ because they are the things which are being manufactured in such a way. So why we are talking all this? Because this is a process being invented. They could find they have. This is the equations will be never be destroyed. Never will be destroyed. These calculations will be lifelong. Next generations will also should be studied this. Got it? So this is the basic kinematics we are studying. how this particle helps to glow the light, how this rotational motion is helping to rotate and to calculate, and how these tires are being invented, how this has been added to a rigid body, and how this rigid body is moving from one place to another place. How the beauty of this subject, you please understand the beauty of the subject. Okay. So this is the relation between linear and angular kinematics for a particles in circular motion. So if it is moving the circular motion, the particle is nothing but if I'm taking a tire, it is moving in a circular motion. So it is the displacement, the velocity, the angle, acceleration, everything will be in a circular motion, right? It is continuously rotating, 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 and it is not having any disturbance or distraction for this. So I am finding the relation between linear and angular kinematics for a particle in circular motion. So particle means I can take a tire or I can take an electron also. Got it? I can take both the examples and I can tell you. I can explain you. So here how this angular. So here what they are telling, non-uniform rotation of a rigid body about a fixed axis to the point. So this is with this we are going to complete your fourth unit. So next unit will be mechanics of rigid bodies. So here you have two subdivisions how this mechanics of a rigid body works. So here you have a center of mass, motion of a center of mass, reduced mass, torque and rotational motion, conservation of angular momentum. So now you understood what is rigid body. Now you understood what is mechanics. So then if I am talking about center of a mass, motion of a center of mass, reduced mass, torque is nothing but if you are giving some external force to that, how it rotates, uh, how that mechanism works for that motion. So conservation of angular momentum. These are the topics to be discussed. So this will be the next extension of your rigid body. Okay, so these are the topics. So what is the introduction? The motion of a body can be described if we know the forces acting on it. In this unit, we shall discuss the concept of the center of the mass and its motion. So further, next concept of a mass, how this mass takes place, how this mass of a weight is going to be helpful, how this can be calculated. That is what is being explained. So if you understood what is a rigid body, what is angular velocity and acceleration, this will be so simple. You're just going to find the mass velocity again. So center of the mass. So if I'm taking a circle, okay, center of the mass, I just want to calculate. So that will be the calculation. I can find out for the x-axis, y-axis and z-axis. Understand? I'm just going little further because if I'm done with this, we can next class go for the next topics. Further extension of this acceleration, whatever the center of the mass of the system of the particle. Okay, so mass means nothing but I want to find for here, here, here for the x-axis. I want to find for the y-axis, here, here, here. Z-axis, if I'm taking Z-axis also, I can find. For if I can find for x-axis, I can find for negative also, right? So where I'm going to find the masses for the x-axis, direction which is showing. That might be forward, that can be reverse. Center of the mass of a rigid body. Rigid body means which is fixed and I want to find for the mass of that. Okay, that might be any shape. That might be circle, that might be empty or square, triangle, rectangle, whichever the shapes, the symmetrical structures. I want to find, I can fix the center of the mass for that. I can find the angular displacement, velocity, whatever I want, I can find for this. Okay, so what is reduced mass? So what is that? A small mass M coupled by spring of spring constant K to a rigid support is a simple harmonic oscillator. This is a two-body system in which a rigid support serves as a body with infinite mass. Infinite mass is nothing but reduced mass. When the mass M attached to the spring executes oscillations, the rigid support remains at rest in an inertial reference frame and the potential energy U of x of the oscillating system is a function of the displacement x of the mass alone. So in nature, we find two-body oscillating systems in which we cannot consider the mass of the one of the bodies to be infinite. M molecules such as H2, CO, HCl, etc. are example of this type. They oscillate along with their axis of symmetry. We have to consider the motion of the both bodies in an appropriate inertia difference frame. Means we are going to find for the fixed body and we are going to find the masses M1 to M2. So I am able to have added a string to that. That is K. If the force is applied for M2 to M1. So the force which is coming in this way will be the negative. This will be the negative force, this will be the positive force. Okay. So here A and B, x is equals to x1 minus x2 of minus L. Nothing but L is nothing but the distance. I just want to find the distance of the string from here to here. Simple. So nothing complicated. With this, you can understand how I am able to find for a mass of a center of the center of a body. The center of the body is fixed. If I'm taking x-axis, y-axis, z-axis plane, for ultimately we are going to find with the simple x-axis. The masses can be calculated from M1 to M2, M3, M4, so on. Okay. Next topic, extension of that. And somebody told me that group will be created so I can share you some important questions or important topics.
Actually, madam, officially we don't have group, but I have created a group with BSc students physics subject.
Now, please, you see, take your Mr.
Yeah, Vinod Mishra.
Yeah, we know, right? So,
Yeah,
what others know, please share your number to you. You share your number to others. So, what happens? Definitely, they'll add in your number, no? You share
I
your
have,
number. No, you have created a group and others want to join me. They should know your number, no?
madam, I have shared the number last time, and I think everybody has joined.
But you didn't add me. I'm not in any group.
This is my number. I just sent.
Hmm. You have my number, right?
No, last
I,
time you have not shared.
no, I've given, no? Already I've shared my number.
No, madam, will you please give it again? Last time I didn't get.
Hmm. Just I'm typing. Okay. So
Yeah,
add me in the
yeah.
group. So it will be helpful for you people to prepare for your exams. Okay. So next is nothing but torque. Torque and rotational motion. Torque and rotational motion is also simple. See, if I'm giving some external force to torque is nothing but giving some external force to that rotation. It starts rotating. Okay, so that is about the interaction torque acting on a particle, angular momentum of a particle, angular momentum of system of the particles, kinetic energy of rotation, momentum of inertia, which moves from one place to another place. So moment of inertia of a wheel. So talking about a wheel. So wheel is there. Everything with the help of the wheel only, the things work. If I'm taking example of a sugar cane, so it starts rotating. Once if you are giving some external force to that, it starts rotating. And you are able to get a proper juice and you are going to have. So how this is going to work? How this momentum of inertia of a wheel, moment of inertia of a homogeneous rigid rod. Okay, moment of inertia of an angular cylinder, parallel axis and perpendicular axis theorem. So next class, I'll just give you a glance about these topics. I won't teach you much depth because it is simple. Simple topics, you please go through it because other topics I want to discuss. Clear, ma? Okay. Even if I
Yeah.
don't wind up, class will be automatically disconnected. So we'll try to discuss another topics also. Okay. So share me if you have any doubts. I can talk to you people later. See you in the next class, everybody. Okay. Vinod, are you there? Okay, ma, see you all in the next class.
Okay, madam. Thank you.
Yeah, please study
I have
well.
added you.
Sorry,
I have added, madam. You are in the group.
you have added? Okay.
Yes.
Okay,
Okay.
fine.
Thank you, madam. Bye,
Yeah,
madam.
most welcome. Most welcome.